All right, welcome everyone. Thank you for joining us. My name is Katie. I'm a member of the reference staff at the Napa Library. Dr. Mark Teaford is here with us this evening for part three of a three-part series called "What Are Primates and How Do They Live in the Wild?" My colleague Chelsea will be joining me at the end of the talk and will handle the Q&A portion of the program. You can type in your questions at any time during the program, and Dr. Teaford will answer them after his talk. So we'll hold on to them and then read them off to him at the end. Dr. Mark Teaford is an anthropologist and an anatomist and is currently a professor and vice chair for the Department of Basic Medicine at Touro University in Vallejo. In this final installment of this series, Mark will be concluding with a discussion on apes. So it's my pleasure to introduce Dr. Mark Teaford.
Well, thank you very much. This is always such a pleasure. So I'm going to try and share screen here, make sure I've got the right ones going here. Let's see, there's that. Come on, there we go. So this is just from the flyer. If any of you have seen the flyer, just the same basic info that we just went through. So is this. It's the last of the series. And I'm going to make sure I have my little pointer up. And this is one of those that there's so many things we could talk about. So I've just picked a few topics here. I was talking to people beforehand, and this could easily be one talk on chimps, one on gorillas, one on orangutans, one on gibbons. There's just so many things out there. They're our closest living relatives, and so lots of work has been done. But before we go to that, if any of you saw the very first of these on prosimians, it's a fascinating article in New York Times 2 weeks ago now, where they're basically, it's from the Duke Lemur Center, where they're dealing with a situation where they take care of these lemurs so well. You have these individuals who are post-reproductive age, and when they get to that point, they don't socialize much. And so what the researchers there have done is they've begun basically associating different species together as friends, snuggle partners. And check it out. Look at New York Times, cuddles and grooming. It's just amazing, an amazing story. So anyway, enough about that. Those are from this end of the primates over here that we talked about the first time. Now we're into this section. You can tell that even this chart is a little human biased, because look at all the different things that are listed here. And if you saw the last one, boy, there are so many monkeys that are not listed here. But anyway, so gibbons, orangutans, gibbons, both common chimps and pygmy chimps. We won't talk much about humans in this. So we're talking primarily about apes today. They have a rather limited distribution. So notice chimpanzees in the brown here, okay, and in this little patch here, and this little patch here, okay. Central Africa and West Africa, gorillas, that sort of greenish color, even more restricted, and then gibbons in Southeast Asia, including islands of Indonesia, and orangutans restricted to islands of Indonesia. Now, in the past, there's a period called the Miocene, 10 to 15 million years ago, where they were much more widespread. So the black represents the distribution today. The gray is monkeys, but all these little diamond shapes are fossil localities in other places. And look at where they are in relation to where the modern distribution is today. They were much more widespread in this Miocene age, including many, many apes in Europe, for instance. So that's a contrast. The little diamonds represent just specific sites. Realize that's grossly underestimating distribution, because the only way you find fossils is if they're preserved and if we discover them, et cetera, et cetera. So, there are probably many, many, many more places that where the ape materials were just not fossilized. So apes were more widespread in the past. That's the bottom line there. So here's another snapshot of some of them. Okay, orangutans, chimpanzees is just a common chimp. gibbons, siamangs, which are closely related to gibbons, and gorillas over here, and humans, of course. Now, in the past, what we've done is we stepped through anatomy and then behavior and then ecology. Here we'll sort of swoosh together behavior ecology a little bit, okay? Because there's just, again, there's a lot of things to choose from. But anatomy, they're in a variety of shapes and sizes, okay? As I'm sure you probably know, gorillas are the largest living primates. I mean, some of them are just massive. This is just sort of a guesstimate of average body size, etc. here. So you get some idea. 5 kilos up to over 175 kilos. And so, you know, that's quite a range, basically. And it doesn't show, I mean, pygmy chimps and common chimps, pygmy chimps slightly more gracile, so they may not weigh quite as much, but otherwise fairly similar to each other. Males are generally larger than females in apes. However, in gibbons and siamangs, they're equal size. And as you see in this shot here, the females are beige in this species, and the males are black, same species. So you have this color contrast between males and females. Keep that in mind because we'll see them again in one of the upcoming little videos. General anatomical characteristics. Apes have no tails, so here are monkeys and prosimians around here. There's another monkey with a little tiny stub tail, and all of the apes and humans don't have tails. All right, so that's a fairly common difference. Other differences relate in large part to the chest and shoulder region. Okay, we'll talk about a couple others in a second, but here's a monkey chest. So we're looking down from the head down towards the toes here. So this is basically the chest wall. This is the shoulder blade back here. The arm would be hanging off here. And a couple things to note. We have apes and humans have very broad chests, not as deep, relatively speaking, as monkeys. All right, and our shoulder joints are pointed a little more out to the side, okay, and that gives us more mobility in certain types of positions, all right, than you would find in many monkeys. There are differences between ape species for sure. If you make their trunk sizes equal, okay, so notice here's that massive gorilla, and the trunk size here is the same as for the gibbon, but look at the difference in the limbs. Okay, gibbons have much longer arms, all right, very long arms. Orangutans have pretty long arms. These are the genus names for them. Hylobates, Pongo for the orangutan, Pan for the chimp, and gorilla has the same genus name as its common name, all right. So these long arms are related in part to locomotion here. Gibbons have a very remarkable way of getting around in the trees. I'm going to turn this off for a second here now, and we'll see if we can get this up here. Come on, there we go. And whoops, come here. Slide this over. Now, what I'm going to do is I'm going to jump forward here. This is one of those species where the female is beige and the male is black. And there's the female with the baby. Okay, I can turn this on your narration to a music.
Little sister, Raya.
Little tiny one.
She still needs a lot of looking after. As a baby, she's even paler in color. Her fur won't get its true adult coloring for another 5 years.
But now we get to see get an idea of how they move.
A well-traveled trail through the forest.
And if you've seen them in zoos,
they follow each other in single file.
Here comes the female with the infant. The infant just clinging on.
Mom, carrying Raya, pursues Dad, with Samar bringing up the rear. Moving through the forest canopy requires incredible skill and dexterity.
Now, a thing to keep in mind is that they can move incredibly fast through the canopy, akin to what we see with spider monkeys in the New World. We once tried to follow spider monkeys as this is called brachiating, swinging by their arms in the trees. And we're on the forest floor trying to run after these things, and there's no way you can keep up with them. Just not a chance. It's pretty incredible. But
Samar's father
Oops,
is a real expert.
I'm going to get back to here. Sorry. There we go. And can orangs do this? Oh, yeah. Now, if you've ever been to the National Zoo, okay, in Washington, it's pretty amazing. They have these towers up so the orangutans can come out of their enclosures and go up on these towers and go above everybody on the walkways below. They've had to modify them a few times because sure enough, within the first year or so, when they first set it up, one day, one of the orangs figured out a way to get down off the tower and was walking around amongst everybody in the zoo. But anyway, they figured that out. But check this one out now. This is a baby also and a mom getting a chance to walk on this tightrope-like thing. Look at the little baby there going. It's like 80 feet in the air in Washington, D.C. Watch the baby here. Oh yeah, they're pretty comfortable. Okay, so they can get around in the trees. Even the large adults can. Pretty astounding. All right. So yes, these long arms do come in handy. Oops, I keep leaving us on that one. Here we go. Now, contrast to gibbons. Chimps and gorillas spend more time on the ground. And when they do, they don't walk with their palms down. They walk use their knuckles. Okay. So we're going to use it. Here's a male gorilla in a zoo. Okay. And you can see here his feet are flat. Okay. But he's resting on the middle digits or the middle portions of his hands, sort of on this part here. So we'll get a little video of that just to show what that looks like. This has some sound. It's in a zoo. You can see hear little kids in the background. But just watch how this male, it's a silverback, so white back. Watch how he moves. Here he comes into the picture. Pretty impressive. Of course, it doesn't show them running or anything like that. Interestingly, there's subtle differences between the wrists of gorillas and chimps. So the gorillas, as you might imagine, they're big, okay? And so these joints are lined up more to give support, all right? Whereas in the chimps, they aren't as big. They are probably more dexterous, okay? And you see that reflected in portions of the wrist and elsewhere in the hand too. How do orangs walk? They use what we call as fist walking. Look at the hand very carefully, sort of wide, walking on the side of the hand, sort of like on this portion of the hand. Just kind of interesting. Orangs, they have long hands, which they use very, very well in getting around the trees. And they have relatively shallow hip joints. So even in this large male, they could get their legs straight out. I mean, there's a classic shot of a younger male with his legs up like this. Okay, it's just amazing how flexible they are. Again, to get around in the trees. Humans have a rather bizarre way of moving on the ground. All right, walking on our hind legs, that's just strange for mammals, really. And along with it, we have relatively long lower limbs. Okay. Just think of it this way. Here's a gorilla, not probably a little small scale wise, but notice that even with the legs relatively straight, the gorilla can bend over and just basically touch the ground easily. All right. In humans, you can't do that. Okay, unless you're bending really hard to reach down there. Okay, it's difficult. All right, because our legs are long. Also, our feet are different. We don't have grasping feet. Clearly, they've been modified through time because they're supports, basically. They help support our weight and give us stability in walking. Another interesting feature. Now, this one here is a little bit of anatomy. So I have to give you some basic location here, just assuming some people know this cold and other people have no idea. This bump here is your Adam's apple, right here in the middle of the throat, that bump right there. Okay, so if you turn this structure around 90 degrees, here it is, and you've sliced it this way, like right there. there's that bump again. All right, so this is in front and this is in back. Now, instead, if you went down like this, you'd get a section like this. So right here is this piece of cartilage here in section. All right, this one here is this piece right there. But what all I want you to see is there's a little space here. Here's the vocal cord right here. And this little space here. In humans, it's nothing. It's a tiny little space. Yes, maybe it helps help determine what our voice is, okay, in some ways. All right, but it's a tiny space. In apes, they have an expanded air sac there. That space gets really big. Here is a siamang. That's that space expanded. All right, here's the larynx. It's a very crude drawing, but this is meant to represent the larynx. And here comes that space. Look at how big that is. All right. Here's a chimpanzee here. Same sort of thing, different view. So you can't see the extent to the side, but you get some idea. And looking from 4 months to 4 years, that space is getting bigger and bigger and bigger. All right. And that space serves as among other things, a resonating chamber. You run air past it and it can accentuate. It's really like blowing on the top of a bottle. Okay, and it allows these animals to create some amazing sounds. So here's one for siamangs, that one with the expanded air sac we saw there just a second ago. And I'm going to pull this over. This does not have a video with it, but hopefully you can hear the sound. Pretty amazing. And it's a pair duetting. So you have the low sound and the high sound. And they are usually the male and the female trade off in quote unquote duetting. So the male creates one sound, the female creates the other one. You can hear those sounds for well over a mile. Okay, it's pretty astounding. Let's look at behavior a little bit. Okay, remember this little diagram from before. If you saw the previous shots, they're all previous talks. There are a variety of social organizations that primates have. Apes, you only have what, depending on how you count them, like 5 different types. And it's like there are 5 different types of social organization. Pretty astounding, the range of differences you find. Gibbons are monogamous, gibbons and siamangs. So here's that beige female, black male, and they stay together. They stay together. Their infants grow up in that group and then may leave eventually by like age 10 or so, something like that. But basically, it's like a little family, all right, with the male and the female together with the infant, or infants in some cases. Contrast, orangs, this shot here is meant to represent the black is the male and the white is the female and infant. The female and infant form a social unit, okay? And the males just sort of circulate between those. All right, so the male isn't there all the time at all, okay? The female and the infant are the main social unit, social bond, which is kind of interesting. We'll come back to that in just a minute in another aspect of it. Gorillas, multi-male, multi-female groups, okay? So this is from one of the classic sites, Dian Fossey's in East Africa, where this one group with this male that lived for a long time, he lived for like 35 years, I think it was. I can't remember exactly. They named him Pablo. And at one time, that group was like 25, 30 individuals. Okay. So you have the male, the adult males have the silver back. Okay. And the females, your infants riding on the back of the females. Okay. Large group, males and females together. Pygmy chimps, same sort of thing, okay? Large groups, multi-male, multi-female, infants are there, et cetera, et cetera. You know, it's similar in that way. Common chimps, though, they have that arrangement, but they also, it depends on the situation and it depends on exactly which geographic site you're talking about. So it varies kind of dramatically, and they can come together this fusion fission, or split apart under certain circumstances. And certain sites, I mean, you've probably heard of Gombe Reserve in Tanzania, where Jane Goodall worked. That is really a small site because it's hemmed in by farms and a lake. All right, so there's a limit to how big the groups can get. All right, other sites where they're bigger, where they have more freedom to, you see this fusion fission stuff more often. Pygmy chimps, they don't do that. All right, the standard argument is they're in Central Africa with no resource shortages to speak of. All right, and as a result, they don't need to split up into smaller groups or anything, whereas some chimp groups do because their habitats are different. A little bit more on these home ranges. So here's a schematic map of different home ranges for different social groups. Each letter represents a group of gibbons in this case. Small home ranges, 40 hectares. Remember that big area where we studied howler monkeys mentioned last time? You know, that was like 1,500 hectares. The social groups were on this size, but you know, gibbons generally, this long call they use is generally keeping other groups at a distance. Okay, they generally do not, you know, go forward and attack other groups. If a group does come close, you know, they will approach, but they'll call back and forth to each other. And they're classic playback experiments where you play the sound of a group, a different group, and the home group will come and investigate, that kind of thing. But you know, pretty much they're isolated groups, but they do basically tell each other where they are. Orangutans, normally they would have, you know, the males would be roaming over, you know, large areas, 2,500 hectares, 800 for the females. Nowadays, with all of the things like oil palm plantations, etc., in Indonesia, this Borneo and Sumatra, the forest habitats are getting very fragmented. All right, and so you have much smaller groups, and in some cases, you know, isolate. I mean, here's a place for a female. The green represents trees. Very few trees in that particular area, and the blue lines or arrows are the males circulating through. Sometimes you'll have, because of this forest fragmentation, you'll have more than one female together in a larger group, and it's in part because of this habitat destruction that this is happening now. Gorillas have some home range overlap, so the different colors represent different groups here. This is Bwindi in Uganda, and so there's some overlap there, but their territorial interactions are primarily display. And the classic cartoon images of the gorillas beating their chest, it's actually true. You know, it's sort of I don't know if you can hear that, but it's a very rapid sort of sound. And you can hear it surprisingly far. And what the males in a group will do is if they hear another group nearby, they'll do that and then hear for a response. If they get one and it seems to be coming closer, that same chest beating from another group, then they'll go off to investigate. Now that they could have some battles there, but oftentimes what happens is it's not the dominant white, you know, silverback male that goes, it's the younger adult males in the group who are not quite the boss yet. All right, they go off and investigate, and if there's a fight, well, they're the ones that get dragged into it. But many times it's, you know, just the chest beating will warn them off, sort of like the gibbon long calls. Again, different. Chimps, highly territorial. Here is one map. This is actually from a paper looking at the spread of disease and stuff among groups, but they overlap very. The density of the color represents their daily paths. So they're sticking in these areas here, and yeah, they're very territorial, even to the point of having patrols. Here's one from Kabale Forest in Uganda, where at this site, you know, the males will go off on these patrols, and if they find anybody from another group, well, then there are two options. If that other group is bigger, then they might just make a ruckus and then back off. But if the other group is smaller, they may well attack. All right, and that was one of the discoveries from Jane Goodall's work, where initially, everybody thought, oh, cute little chimps, and look at them, and oh, aren't they neat? And they're human-like, and all this kind of stuff, and didn't really recognize the fact that at Gombe in particular, because it's a small site hemmed in, there were some battles between groups where individuals actually got seriously wounded and or killed. So very different than, say, gibbons, where you've got these calls that pretty much keep people away. Other gibbons away. Very interesting contrasts in their home ranges and how they use them. Now, most apes live in forested environments. This, tropical rainforest swath here, this is where gorillas are. This is where orangs are. Gibbons get up into some of these areas where there's slightly different forests. Obviously, they got to have trees. Okay, so that's different. And so, tropical rainforests are a primary habitat in the old world. Remember, you don't have apes in the new world. This has left African apes, in particular, susceptible to certain tropical diseases, most notably Ebola. All right, and so here is a map of ranges, if you will, of different gorillas and chimps in Africa. All right, and so you have some areas here where basically green is just chimps, this olive sort of color. All right. Here is one little tiny, this Cross River gorilla group is this little tiny thing, the black one there. Western lowland, eastern lowland, and mountain gorillas over here. But that pretty well, that covers tropical rainforest there, all right? Here is a map of human Ebola outbreaks up through 2014. This is an article in the New York Times. And lo and behold, look at that. Human outbreaks, and it matches up pretty well with this distribution of apes, okay? And this has left the apes susceptible to this, all right? Yes, maybe it originated with certain species of bats, okay? But humans are generally developing this through contact with either the bats. One of the original cases was probably a little kid playing in a tree the bats roosted in. They would capture the bats and sometimes eat them, all right? But then other times it's from contact with infected ape materials, dead apes, basically. Some outbreaks have caused 90% mortality rate in gorillas and 75% in chimps. Just stunning mortality rates. I mean, this is right up there with humans, just as susceptible as we are to this. Granted, the figures vary tremendously between sites, but just you want to pull out some figures that will, make you stop and think about it. It's, they're susceptible. Rumor. It's very hard to document population sizes, okay? But at some sites, people have thought that this has caused over a 30% drop in ape populations in certain areas, even 2/3 drop, okay? So, yeah. Now, different thing to notice here is that here's a slightly different map, okay? What we're showing here is different species of chimps and tree cover, all right? So if gorillas are in this area, and this area, okay? Notice the chimps come up into areas where you have less tree cover, all right? They're getting to more open habitats than gorillas do. This may have contributed to two of their very interesting behaviors, at least from a human perspective: tool use and hunting. 50s and 60s, as we touched on last time, anthropologists felt there were two distinct behavioral traits for humans: our ability to make and use tools and our capacity for organized hunting. These were two classic books of the time. Just the title sort of says, well, there's a mindset back then that was slightly different. It's not ignoring 50% of the population, but the point is that hunting and tool use were thought to be crucial for humans. Well, people were aware of the fact that, say, carnivores, for instance, wolves, had organized hunts, okay? we didn't really know a lot about our closest living relatives. This is where Jane Goodall's work is just seminal. I mean, she just redefined what we thought of as tool use and hunting in other primates. Since then, all kinds of work has been done by many, many people, okay? And it shows how little we really knew about these things, okay? Tool use in chimpanzees, obviously from the Goodall Institute here. This is one of her most famous chimps of the site, Flo. This is one of the offspring of Flo, but using twigs, basically. You pick twigs or thick grass stems, and you pick the twig, you make it the right size, you take off any side shoots, etc., and then you can stick it into termite or anthills, and the soldiers will grab onto it. You pull it out and just sort of, and you just take them off, basically. It's a little snack, if you will. All right. And that was earth-shattering when it was first described. It was amazing because they were actually, quote unquote, making these tools. Here is another video here. I mean, the sound is on, but the thing is to watch the mother and the infants here. Watch what's going on with these. And I will pull this over. This is from the Leakey Foundation, which supports a lot of this sort of research. Bear with me here. I'm going to expand this so you can see it a little better. There's the mother preparing this twig. There's the infant watching. She says, oh, there's some ants. Okay. And the infant's more interested. It's almost like the mother is showing. The infant says, oh, I'll try it. Let me do it. It happens here on the forest floor. This is, classical anthill. Okay. Mom is basically, showing the infant how this works. Okay. Pretty astounding. Pretty astounding at the time. There are lots and lots of things that have been done with this kind of behavior here, where, opens up all kinds of possibilities. Are they teaching their offspring? Who's learning this stuff? Who's passing information on? How does it stay in the group? How does it differ between groups? All kinds of questions. Same sort of thing with other sites where they're using stones, in this case, an anvil and a quote unquote hammer to break open nuts. Right? Same sort of thing. And again, classic examples of infants watching mom do this, or older adults in some cases. Okay, so just astounding to watch them and think of what's been done in the way of research here. And how do they do this, and how is that information passed on? Well, here's another site. Okay, this is Senegal on the western tip of Africa. Okay, so this is up in this area here, obviously a very different habitat. This is savanna, and there are chimps living there. Okay, there are chimps living there. And it's a very open habitat. It's sort of akin to the dry season in the site that we worked at in Costa Rica. The trees don't have a lot of leaves certain times of the year. There's not a lot of, there are no monkeys that live in the trees. There are some terrestrial ones there, but it's a different sort of habitat. Well, this is the site of an amazing discovery where they don't have any monkeys to go after. We'll come back to that in just a second. So what do? Well, in some cases, and in this case, oftentimes the females are doing this. Check this out. They grab sticks, they pull off the side shoots, okay? They chew on or run it through their teeth to make the end into a point. And then they explore trees that have holes in them where, unfortunately, bush babies like to snuggle up. Bush babies, remember, are nocturnal. All right, so they're sleeping during the day. The chimps come by with these sticks and sitting there going after the bush babies. And the descriptions are kind of gruesome, where come in and see if there's any blood on it, etc. But they're using spears. They don't have stone tips on them, but to basically help hunt bush babies. It's an open habitat. There are no other monkeys there. The examples from group hunting in forested habitats is kind of frightening in its own right. Kabale Forest. The chimps are so successful, they've caused a drop in the colobus monkey population. Red colobus and now black and white colobus, the numbers are dropping because the chimps have been so successful in hunting them. Here's a classic example. Some of you, or maybe many of you, have already seen this sort of thing, where I'll just give you a little glimpse of it. It's Richard Attenborough in his, I can't remember which of the series it was, but it's, oh, we have to have a commercial first. Wait just a second here. Let me get, come on. Come on. I have to get by the, come on. But the point here is that you can hear the chimps in the background.
From the purposeful way in which he's walking, it's clear that the search for prey has started. The other members of the team are not far away.
And, but see the monkeys begin to get nervous. And watch the chimp look up there, following them. And what we don't have time to go through here is that the chimps have divvied up duties. You have some that are chasers on the ground, some that are basically guarding certain escape routes on the ground in trees, and some that are basically going to run up and grab whatever monkey they can. Look it up, hunting chimps, hunting monkeys, any sort of video, and there are multiple videos of this, where it's scary to see them in operation like that. Whoops, sorry, I did it again. I got the wrong thing. Here we go. Interestingly, some monkeys make use of this because colobus and Diana monkeys, the Diana monkeys are lighter, more often the periphery, oftentimes not caught as often. Basically, they help each other out a little bit. And so when chimp calls are formed, these two different species come together. Or if the chimp calls are played like in the evening, those groups stay together in the morning. It's like, okay, we're basically helping each other out here. So it's an amazing series of discoveries. So now we're going to talk, we have enough time. Okay, we're going to talk a little bit about attempts to teach language to apes, moving totally out of their normal ecology and stuff like that. The initial studies here focused on trying to teach them to speak, trying to get them to talk like you and I. 1930s, psychologist Winthrop Kellogg and his wife Luella, they had a chimp named Gua. They wanted to raise with their son Donald. Okay, and see, would the chimp pick up language? They were raised together. The chimp didn't get any intensive extra language training or anything like that. The chimp didn't learn any language. Okay. The chimp did learn to respond to like 70 vocal commands. But here's the fascinating part. It was discontinued when Donald started acquiring more chimpanzee sounds than Gua was acquiring human sounds. So Donald would come to the dinner table and start making type sounds at the dinner table. So they said, maybe we better not do this. Okay, 1950s, the Hayes, Keith and Catherine, they're from Yerke's Primate Center, had a chimp named Vicky, same sort of thing with some exceptions. Raised at home from age 3 days to 6+ years. The chimp was given extensive training in trying to formulate words, trying to say things. In the end, she could respond to lots of commands, but she could only manage 4 words. Mama, Papa, Cup, and Up. And all of these were unvoiced. So Cup was, okay, and Papa was like that. There was no vowel sound in there, all right? Now, most people thought that these attempts like this to teach them to speak reflected the fact that, well, put it quite crudely, chimps were too dumb to pick this up. This just, they couldn't do it. But it wasn't until the 1960s, largely because of this study with Vicky, people realized chimps can't produce some of the sounds we do in the same ways. So in a way, they're at a disadvantage. Is this really testing their ability to convey information? Okay, and that's a very different question. Yes, they cannot speak like we do, but could they learn a language of some sort? Once people realized this, there's all kinds of studies. Plastic shapes that represented different things and put it on a magnetized board. American Sign Language, you've probably heard of some of this. And even computers, where the keyboard was a set of basic symbols, not letters, but symbols representing different things. Some of the apes have become very famous. Washoe, the first one to learn sign language. Coco, the gorilla, which actually Coco lived down in Santa Cruz. First gorilla taught sign language. Lana, first one using this computer keyboard. Kanzi, a pygmy chimp. Oh my gosh, he was amazing. Did all kinds of things. Still is amazing. Mari, an orangutan, who used a computer, but she had no arms because of a childhood accident, so she used her feet and a joystick. And so get an idea that maybe these apes are rather able to do this. So this has given us all kinds of insights into their abilities, their thought processes, etc. Yes, things like sign language, interpreting, is a chimp using sign language? Okay, you have to watch very, very carefully to pick up the signs, all right? And maybe some of them are a little bit, not quite as exact as you might like, okay? So there's some subjectivity to it there, but still, the insights are kind of amazing, okay? They can talk about something not in the room. Here's one. Washoe wanted a soda that wasn't there. And no sign of a soda in the room. She's signing, please, sweet drink. Please hurry, sweet drink. Please give me sweet drink, over and over again. Talking about something that's not in the room. Talking, referring to. Creating new words. Lucy, one of the sign language chimps, referred to radish as food, and then she took a bite of one, and then it became cry hurt food. Tattoo used the word black to refer to anything she wanted or cherished. Things were black. That meant they were desirable, beautiful, cool. This black. She would say, she put on some lipstick, and she'd say she put on some lipstick and looked in a mirror and said, "This black." So just different uses of words. Change the meaning. Lucy got frustrated because she couldn't get a food item from one of her trainers, so she waved him out of the room and called him a green poop. Okay. Washoe, this is a classic example here. She's sitting in a room all by herself. Nobody's there. She's sitting all by herself. She's working with a piece of paper. She notices a rope ladder off to the side. She signs, up, hurry, and goes up the ladder, comes back down, and then grabs her piece of paper and with that for a little bit, and then looks over and notices the rope ladder again and says, more up, and goes back up and down again. Okay, so she's basically talking to herself, but giving us a window into how she's thinking. Coco, many intriguing situations. She had a tabby cat as a playmate. One time Coco was upset with something and ripped a steel sink out of the wall. When the trainer came in, caretaker came in and said, "What happened?" All in sign language. Coco said, "Cat did it." Okay, so just an insight into the gorilla's mind. She liked watching TV. One of her favorite shows was Mr. Rogers. When he came to visit her once, what did she do? Well, one of the first things she did was she took off his shoes, because that's what he did at the start of each of his shows. Again, amazing. Lana, one of the first chimps. I have to just sort of read this one to you, because this is funny. Object Lana clearly wanted was a box of M&Ms. She had seen Tim, her trainer there, put the candy in the box, but she had not been taught the lexigram. This is one using the computers, so not sign language, the computer symbols. She had not been taught the lexigram for box. So she was asking for that container when she said, "Tim, give Lana this can." That's a question. Tim, through his own keyboard, replies yes and gives her a can, but it's empty. It doesn't have any M&Ms. Lana returns and says, Tim, give Lana this can. And Tim says, I don't have any other can. No can. Then she says, Tim, give Lana this bowl. Whereupon Tim said yes and gives her an empty bowl. Then, as though Lana thought someone else might be more helpful, she asks a question, Shelley? And Tim has to say, Shelley's not, she's no Shelley. So Lana types, again, a question. Tim, give Lana this bowl. And then it's like she stops, erases it, and says, Tim, give Lana name of this. Tim replies, box name of this. As though grateful, Lana replies, yes. Then says, Tim, give Lana this box. And she gets her M&Ms. Okay, so insights into the thought processes. Do apes have long-term retention of these languages? Yes, they do. Here are two classic books from two of the major researchers on these chimp language studies, Dwayne Rumba and Roger Fouts. This is a story. I'm just going to post this 2020 thing. Fouts worked with a chimp named Bowie, who was born unexpectedly in a research lab, and as a result was taught sign language. He was moved to a lab where he taught sign language, and that lab was used for many years. I think it was 7 years, 9 years, I can't remember exactly, for sign language studies. Then the owner basically was running out of research money and agreed to work with a pharmaceutical firm. As a result, the chimps at that facility were moved into isolated cages, no stimuli whatsoever, no social interactions, all right, and basically served as big petri dishes. Bowie was one that was basically injected with hepatitis, all right. 15 years later, 17 years later, I can't remember, Fouts tracked down where Bowie was, and back and forth communications with ABC's 2020, they actually did a segment in 1995 where, this is 15, I can't remember, 15 years, 17 years after Fouts had last seen Bowie. They come into this facility. There's Bowie in this little cage, this full-grown chimp in this little cage. And what does Bowie do? Recognizes him right away, comes running over, signing, hi Raj, hi Raj, hi Raj, me Bowie. And they have this conversation, and it's tear-jerking, really. I mean, I just can't show it. I'll just break down. So if you want to see it, look up 2020 Bowie and Roger Fouts. Okay. It'll tug on the heartstrings, that's for sure, to see animals kept this way. After this, within months after this, the chimps were put in a sanctuary where, pulled out of cages, et cetera, and no longer subject to research. I mean, Bowie still carried hepatitis, but at least he's not in a cage like that, and he can interact with other members of his species and human trainers and even do sign language. Okay, so some positive comes out of that. So bottom line, we have a lot to learn from apes. Here's one thing that's just making the rounds recently. It's actually 5 years old, from the Barcelona Zoo. I'll put this on. Let's see if we can get this up here. Here we go. Yeah, let's pull. Come on. Here we go. Watch the orangutan's reaction here. Oh, monkey. I like it. Not a monkey. Oh, you can't hear the orang's laughter, but it's just like this is pretty amazing. Now, is it staged or not or whatever? But clearly, we have a lot to learn from apes. So I'm going to finish with that, and we'll go back to. I'll stop sharing and see if we have any questions here.
All right. Thank you so much, Dr. Teaford. That was really great. So now we'll move on to the Q&A portion where my colleague Chelsea will read off questions in the chat. If you haven't done so already, please feel free to type your questions in the chat and Chelsea will read them off.
All right.
Okay. So let's start off with this first one. Is there evidence of evolution in regards to apes' use of tools? Have the tools gotten more advanced over time?
Not that we can tell yet, but you certainly see differences between populations in which ones are using them, which ones are not, which ones are using certain types and not. But if anything, there's some fear that in some groups, since it is often the younger individuals who are the innovators, if you will, that maybe there will be some changes through time. But we haven't, not that I know of. I don't know that we've got enough data on that yet. Now I might be missing something. I might be missing changes in how they're actually making the tools, etc. But I don't know, for instance, of any where they're like modifying the stones they're using for the pounding of nuts, for instance, that kind of thing. So great question. It would be the next thing one of the next things to look at for sure.
I mean, if I could add on to that, what about, has there been any changes maybe based on interactions with humans as far as tools?
Not so much. Not so much. I can't think of any. I mean, we could go back into how could they possibly come up with some of these things, but I don't think anyone has actually posited that they're getting sort of hints from humans, in other words. But again, there's only there are not that many sites, so it'd be great to have more data, more sites over a longer time for sure.
Mm-hmm.
Any other?
Okay, let's see this next question. Are there any potential explanations as to why gorillas walk on their knuckles? It seems like they would have less stability compared to using their flat palm.
Yeah, that's a good question. It probably goes back to their ancestry, where some of the earliest ape-like primates had very they would walk sort of palmograde. They would walk with their hands like this, and yet you want to basically combine that with a degree of mobility in the shoulder, etc. And so you're trying to get the best of both worlds. You want the flexibility in the hand, you want the support in that hand, and the net result is that there were certain changes in the wrist that basically facilitated both. Now, that's a bit of a, that's not a real explanation in a sense, because quite honestly, we don't know for sure. We have the very early ones that look sort of monkey-like, and then we have some gaps where, it would be really nice to have something in between fossil-wise where we could tell a little bit better exactly how this change occurred. Part of that one shot of the wrist of chimps and gorillas is part of a paper where they're talking about some ideas on why those two are different, but it still doesn't explain why did it happen in the first place. So yeah, sorry, I wish I had a better answer.
No, that's great.
Mm-hmm.
Let me see if we've got any other questions in here. Let's see. Looks like we've got a quiet group tonight.
Oh, okay. Well, That's okay. So be it. This is one where, if we had the typical Hollywood square sort of Zooms layout where you could see everybody's faces, et cetera, then, I can go through and start asking questions, but it's fine. Some of the material, some of the ape stuff, some of the language stuff is just eye-opening. Some of it's rather old, but still, the fact that you've been able to get some of these insights into how they're thinking is just, I find that kind of mind-boggling. Well, maybe people have other things they have to get to, busy lives.
Yeah, well, or maybe you just explained everything perfectly. They have no questions. They understood it all.
Seems believable. Yeah. Well, it's just I thank everybody who showed up. Glad we're here, and we're talking about trying to do one on anatomy. Sort of how do things work? Like how do we create sounds in speaking, and how do we use our hands and our arms in everyday tasks and this kind of stuff. So we'll see if we can pull that off sometime in the not too distant future.
Oh, wait, looks like we do have a question from Kim.
Mm-hmm.
Let's see. They have to type it out first. Give them a second.
Mm-hmm.
Let's see. Okay, let's see. Looks like it might only be a part. Does the hunting behavior of chimpanzees make implications to human behavior?
Mm-hmm.
Let's see. I think they're in the process of writing it.
Oh, okay. Well, one aspect of it for sure, implications for human hunting behavior. I mean, we're finding that.
Oh, sorry, for implications to our human behavior.
Mm-hmm. There's some eerie parallels in some ways, where in some of the hunting behaviors, for instance, the group hunting of monkeys, a lot of times it's the males that do this. And it sort of matches up with the classic old ideas of, our human ancestors with the males off hunting and the females doing gathering and stuff like that. And is it because we have a small sample size for the ape behaviors or what? And we don't have a big enough sample yet to tell for sure. But even, for instance, in that savanna site where they're using the spears for bush babies, the males will go off and hunt things like vervet monkeys and baboons, the primates that are more on the ground, bush buck, stuff like that. Hunt it, they will go after them. Whereas the females will be the one, well, they aren't the only ones, and the males will do it too, but they do it more often, the spear stuff. So we're seeing some differences between males and females, which is kind of interesting. And then in the divvying up of duties in those organized hunts, you see that oftentimes the males that go up and actually get the monkey are oftentimes dominant males, whereas the males that are doing the scouting on the forest floor or guarding the escape routes and stuff are often not the dominant males. So they're very interesting behavioral parallels there that I would say we're just we're beginning to understand, really. And the more we get to know about this, the better we'll understand, okay, what are the implications in terms of human behavior, human hunting, etc. Oh, I think I see a couple more questions popping up. Okay.
Yeah. All right, let's see. check if there's any other questions. Okay, this is Kim again. Is their hunting only for food, and how much of their diet is dependent on meat?
Oh, great question. It's not chimps. Chimps will eat. If they had their druthers, they would eat fruit. Okay, that's their favorite. And in these groups, the percentage of the diet that's made up of meat is generally fairly small. Okay, in the order of, tiny. Obviously we don't have data on exactly how much are they taking in terms of mass of food or something like that. But time spent feeding, it's in the vicinity of 2 to 5%, something like that. But it could be a crucial source of protein and some minerals that they cannot get from their plant foods. And so another interesting aspect is how do they share these foods? And what ends up happening oftentimes with chimps is that it often gets shared by sort of family groups, in a sense. Family dominant. The dominant males might get first dibs or something, and then share with one of the dominant females, etc. So I should say family. There are patterns of sort of predictable patterns of sharing of the food, which is also interesting. But it is a relatively small portion. They are not carnivores like a tarsier, where it just eats only meat by any means. So yeah, that's a good question. Don't want to give that impression, really, that they're just carnivores, because they are not.
Okay. Kim says thank you.
Most welcome.
Okay, it looks like that might have been the last question then.
Oh, Chelsea, I think that there's one here. I'll read it.
Oh, okay.
Let's see. It says, is there any hope of stopping or having restrictions on the use of animals so cruelly in pharmaceutical labs?
Yeah, it's use of chimps and apes in general has stopped basically in the U.S. The use of even monkeys is now it's difficult in those sorts of settings. Now you balance that with the fact that there's some questions you need answered where you have to have a living organism in order to test certain things. You can't predict it with models and stuff like that, because you don't know all the variables. So yes, for chimps, for sure. There's a large group of chimps in the US now in quote unquote sanctuaries, where they were formerly used for research and are now not. So that's good. But there are still primates used in other forms of research. So it's sort of guardedly optimistic on that. And this day and age,
Okay.
that's a great question.
Looks like that was the final question now.
Okay. Well, thank you again. I just glad
thank you everyone for coming.
And thank the Napa County Library, the people there, for helping. That's wonderful. Makes it possible. So, and
thank you, Mark, for doing all this series for us.
Okay. Whenever we can organize some more, we can do it.
Thank you.
Okay. All right. Take care, everybody. Stay safe.
Have a good night.